All right, let's try to test the convergence of this series 1 over n factorial. Since we have that factorial, root test won't work very well, so let's try the ratio test. So if we're going to write this out as a ratio test, we want to write what's the limit as n goes to infinity of our n plus 1 term over our series. So our series goes on the bottom, 1 over n factorial. On top, we want what would be the same series plus 1. So this would be 1 over n plus 1 factorial. To simplify that, let's multiply by the reciprocal here of our denominator. So on the bottom, these are going to cancel. So now we end up with what's the limit? So n goes to infinity of n factorial over n plus 1 factorial. Okay, how do we solve that out? Well, remember when you do a factorial, let's just say we have a 6 factorial here. That's equal to 6, because that's what we're taking the factorial of, times each thing 1 less all the way down to 1 here. So if we had n factorial, what that would be equal to would be n times 1 less, which would be n minus 1, times 1 less, which would be n minus 2, times 1 less, which would be n minus 3, all the way down to 1. Okay? N plus 1 factorial, what would that equal? Well, n plus 1 factorial, we would start with n plus 1. 1 less than that would be just n. 1 less than that would be n minus 1. 1 less than that would be n minus 2, and so on all the way down to 1. So what would happen then if we had n factorial over n plus 1 factorial? You can see here that all these terms would cancel out all the way down to 1, except the n plus 1. So how we're going to write this here when we do our limit then would be that this should be equal to here, the limit as n goes to infinity of n factorial. We're just going to separate out that first term. So it'd be n plus 1. And then the rest of this on down, you can see, if we take out that n plus 1, looks exactly like this whole thing, which is n factorial. So it'd be n plus 1 times 1 less factorial. And so now we can cancel out those n factorials, and this would just be equal to the limit as n goes to infinity of 1 over n plus 1, because those two factorials here cancel out. And so that limit we know would be equal that would just go to 0, and so we end up with something less than 1. So this one's going to be convergent by ratio test, because it's less than, we get something that is less than 1. All right, let's try another one here. This one you can see also has a factorial. I'm going to write this one when we do our limit here a little bit different though. Because we got this e to the negative n, we could also write this as n factorial over e to the positive n. Let's go with that way of writing it when we do this here. So that one goes on bottom. Our one on top, then we want that plus 1. So this would be n plus 1 factorial over, and this one also would be plus 1, so n plus e to the n plus 1. So now we want to simplify this limit out here. First thing I'm going to do, again, is multiply by reciprocal of the denominator. So if we do that, this is now going to be n plus 1 factorial times e to the n. On bottom, we're going to have that, we'll have it n factorial and a e to the n plus 1. All right, so now with our factorial, we're going to use that same trick we used in our last one here. And so we're not really a trick, but just mathematical equivalent here, that this top one would be same as n plus 1 times n factorial. and on bottom we still get that factorial. With our e to the n, we're going to leave that one. On the bottom, if we have e to the n plus 1, another way to write that would be e to the n times e to the first power. Because anytime your base numbers are the same here, we know that when we put together these, we add the exponents. So this would be the same as what we started with, e to the n plus 1, if we add those exponents together. All right, so reason we wrote it like that is now we can do some canceling here. Our n factorials cancel. Also our e to the n's cancel. And so now we're left with the limit as n goes to infinity of just n plus 1 over e. So now we want to test what is that going to. Well, as we go to infinity, this is going to be infinity plus 1 over e. Well, the plus 1's not really going to do anything. We just have infinity there. Divided by e is still a giant number. This is going to infinity, which is definitely much greater than 1. So this one is a divergent series by ratio test. This is a divergent. All right, let's have you try one out now. See if you can test this one out with our ratio test and see what you get. All right, hopefully you've had a chance to try this one. This is one you could probably also do with the root test because there is no factorial, but I did it with ratio test just to show you that this would work as well. So we want to put the n plus 1 series over our actual series here. I multiplied by reciprocal the denominator, which would give us what we got in this step here. With the two terms here, they're both to the third power, so I rewrote them as a fraction all to the third power. And then with my denominator here, I separated that as 3 to the n times 3 to the first power. These 3 to the n's then cancel out. And so now my limit looks like the one here. Make sure you got that 1/3 there because there's still this 3 to the first power over here. That is a constant, so I just wrote that in front of the limit. Also, this to the third power part, I wrote outside of that because really here's our thing we're trying to figure out right there. What's the limit as we go to infinity of n plus 1 over n? Well, that's just all going to go to 1. And so now we got 1 to the third power times a third, which would equal a third, which is less than 1. So this one is going to be convergent by the ratio test. So that one would be one you could show either by a ratio test or root test would also work. With that last thing, remember if it equals 1, then it doesn't give us enough information. Just to show you that that is in fact true, if you were to do the ratio test with the series 1 over n squared, what we would have here is our n plus 1 term over our actual series. If you multiply by reciprocal the denominator, that would give you this, which would be the same as if we multiplied by 1 over n, we would get that, which would just go to 1. So that goes to 1. Also, if we did it with the harmonic series, very similar, you can see that this also goes to 1. And remember, when it equals 1, that's that one that we can't really use the test to determine. And this shows you why, because we know the harmonic series here is always divergent. Harmonic series is always divergent, but we also know that this series that we looked at on top is convergent by p series here, because our p is bigger than, our p of 2 is bigger than 1. So you can see getting 1 as your answer is inconclusive, because it could converge, but it also could diverge. So you got to use another test you got to use some other test when it equals 1. So be careful of that situation. Ratio and root tests are inconclusive when it equals 1. It either has to be less than 1 to be convergent or greater than 1 to be divergent.